Welcome to the Explainer. Today, we're strapping in and exploring a seriously high-tech analytics cockpit for data center operators. I'm talking about the SuperCloud Composer Release 3.12.0 Performance Metrics Dashboard. If you're managing high-value compute resources, you already know how absolutely crucial it is to have total, uncompromising visibility into your hardware's health and performance. So, let's get right into it. Let's be real for a second. Managing massive AI and GPU clusters can feel totally overwhelming, right? You've got thousands of compute hours, massive thermal outputs, and let's not forget, incredibly expensive silicon to keep track of. But SuperCloud Composer, or SCC, really steps up here as the ultimate solution. It essentially hands you the keys to a powerful, centralized machine. You can monitor and manage the whole shebang from a single pane of glass without losing your mind in the process. Specifically, we're focusing on the Performance Metrics module today. Think of this as a highly customizable, Grafana-like analytics dashboard designed to give you direct oversight of your GPU workload operations. And it's incredibly smart, too. It actually pulls both in-band and out-of-band data. By integrating directly with Prometheus and exporters, like DCGM for NVIDIA or Veka I/O for storage, it gives you this complete, uncompromised picture of your system's vital signs. Okay, let's dive into our flight plan for today. We're going to cover accessing your metrics, appliance versus unit data, visualizing performance, a quick look at hardware nuances, and finally, customizing your view. Section 1. Accessing your metrics, finding the right data. Now, the real beauty of SCC is just how straightforward the navigation is. To pull up your compute resources, it's literally a simple two-step process. Step 1, you just navigate to SuperCloud Composer and hit Performance Metrics. Step 2, you click on the specific system or compute node you want to look at, right there in the data browser. It's purpose-built to get you from that login screen directly to your data as efficiently as possible. Over on the left menu, you've got a super clear path to your performance metrics. And once you're there, the tree view on the right lets you easily drill down through your pods, your racks, and specific IPs. This brings you straight to the exact GPU asset you need to monitor. It completely takes the guesswork out of finding your hardware. Section 2, appliance versus unit data, macro versus micro tracking. So we have two differing scopes of visibility to talk about here. At the unit level, you're getting a micro view. This shows you the metrics for each individual GPU card separately, GPU 1, GPU 2, and so on. Conversely, the appliance level gives you a macro view, showing you the aggregated performance metrics across all the GPUs in that specific system. And why does this distinction matter so much? Well, sometimes you just need a quick pulse check on the overall health of the entire server, but other times you really need to isolate that one specific overheating card that's suddenly bottlenecking your workload. Now, when you're looking at that macro appliance level data, SCC calculates it in 4 specific ways. You've got your max, which pulls the highest value among all the GPUs in that appliance, which is absolutely great for spotting thermal spikes. Then there's min for the lowest value. Sum adds up the values of all the Section 3. Visualizing the performance. Data into visual dials. The min-max average sampling table uses a time series line chart to track performance over a specific axis. Think of it kind of like a flight data recorder for your hardware. In this scenario, we're looking at GPU temperature over time. So say a workload suddenly failed at 2 a.m. You can look back at this exact time series and see right away if an unprecedented thermal spike was the culprit. Now, while that line chart is perfect for looking at historical trends, the gauge meter format gives you this immediate, at-a-glance pulse check. You can see the temperature in bold, right smack in the center, along with a color-coded ring letting you know exactly where that hardware slot stands at this very second. Honestly, it's the perfect widget to have up on a main monitor in a network operations center. But of course, there are times when visual fluff just gets in the way, right? When operators need hard, foundational numbers, like checking the exact storage cluster size, or verifying if an I/O status has actually started, the raw data and status tables are your absolute go-to instruments. They just give you the exact values, clean, clear, and unfiltered. Section 4. Hardware nuances, silicon reporting limits. One thing you've got to know is that SCC is deeply hardware aware. For example, if you're running NVIDIA H100s, you aren't going to see data for active PCI transmit and receive bytes, or certain ECC and NVLink errors. And that's simply because the hardware itself doesn't support reporting them in this context. It's a similar story with the AMD MI300X, which doesn't support reporting memory or GPU clock frequencies, or power capping metrics to this dashboard. When this happens, SCC just displays no records found. But actually, scratch that. You shouldn't frame these as flaws in the software. Rather, it's proof that this is a highly precise tool that refuses to hallucinate data. It knows exactly what your specific silicon can and cannot report. Section 5. Customizing your view. Building your dashboard. I really want you to remember this number. 6. That is the absolute maximum amount of columns you can pack into a single dashboard row inside SSC. This allows for an incredibly dense, information-rich display. Whether you want one massive time series chart spanning the whole screen or 6 tiny raw data widgets packed in shoulder to shoulder, the layout is entirely in your control. All this customization happens inside the Add widget interface. Operators use this really simple menu to select their specific metric, say SM clock frequency, and then they choose their data collection type. Next, you pick your statistical format, maybe a time series line chart, and finally select the chart size. It's a highly intuitive drag-and-drop experience that lets you build a view tailored exactly to the workloads you care about the most. The tools are all right there, just waiting for you to turn raw telemetry into actionable intelligence. Which leads me to ask, as your own AI and GPU workloads grow more complex and demanding, what will your perfect analytics cockpit look like? With SuperCloud Composer, you literally have the power to build it. Log in, start customizing, and take absolute control of your data center. Thanks so much for joining me for this explainer, and keep learning.